Hello students, today we are going to learn in the chapter Symmetry, rotational and line symmetry both for any geometrical shape. So let's learn about this. Draw, whenever if it is possible, a rough sketch. First, a triangle with both line and rotational symmetries of order more than 1. Now when we consider the triangle, so we found that an equilateral triangle has line symmetry more than 1 and rotational symmetry is also more than 1. So a triangle with both line and rotational symmetries of order more than 1 is an equilateral triangle. So its figure for the line symmetry looks like this. Whereas if rotational symmetry, when we consider, so we have the figure looking like this, and we can say an equilateral triangle when it rotated by 120-degree angle, so we get order of rotation, that is 360 upon 120 degree is 3. So here we can say order of rotational symmetry in equilateral triangle is 3, and number of line of symmetries is 3. Now the next question, a triangle with only line symmetry and no rotational symmetry of order more than 1. A triangle with only line symmetry, but there should be no rotational symmetry of order more than 1. So we have a triangle that is an isosceles triangle which has one line of symmetry and its rotational symmetry is not an order more than 1. Next, we have to draw a quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. So here a quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry is not possible to draw when we consider a rectangle, a square, both has the line symmetry as well as the rotational symmetry. When we talk about the rhombus, it has also line symmetry and rotational symmetry, but we have to find out a quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. So there is no quadrilateral. A quadrilateral with a line symmetry may have rotational symmetry of order 1 but not more than 1. It can be order 1 but not more than 1. So we can say a quadrilateral with a rotational symmetry of order more than 1 but not a line symmetry. It is not possible to draw this. Next, a quadrilateral with line symmetry but not a rotational symmetry. Now we have to find out the quadrilateral which has line symmetry but it has no rotational symmetry of order more than 1. Now consider the quadrilateral, that is the rhombus, which has the number of line of symmetry. When we consider it, there are two lines of symmetries, L1 and L2. That is, number of line of symmetries is equals to 2. But it's not a rotational symmetry of order more than 1. When we consider this rhombus, so only in one turn it will looks like as it was previously. So order of rotational symmetry for this rhombus is 1, but we have to find out the order more than 1, so it is not possible. Now according to the line of symmetries and rotational symmetry, give the answers for the following blank spaces. When we have the given geometrical shapes, we have to find out the center of rotation, its order of rotation and angle of rotation. So it is on your screen a square. It has the center of rotation is intersection point of the diagonals. Okay, so this is the square when all the four line of symmetries intersect, that is the intersection point of the diagonal. So this is the center of the rotation, and its order of rotation is when we turn a square by 90-degree angle. So there are 4 turns are possible. So its order is 4, and angle of rotation, as we know, that 90-degree. And how it will be? Like this. Now next, when we consider a rectangle, so its center of rotation will be the intersecting points of the again diagonal, and we know that it has 2 lines of symmetries. So when we consider for the rotational symmetry, when a rectangle turn by 90 degrees, so it will looks as its vertical position, and we have considered it as a vertical position. So now when it will turn about 180 degrees, so it will look like exactly. Then in the second turn again it will goes its previous position. So first when we turn by 180 degree, it will go in this way, and when again it will turn 180 degree, so order of rotation is 2 and angle of rotation is 180 degree. Similarly, when a rhombus, so the center of rotation when the rhombus rotated, that is the intersection point of its diagonal. So this is the center of rotation. And again, when we consider for rotation of a rhombus, so according to this figure, when rhombus rotated by 180 degree, then we get this figure, and in the next rotation again by 180 degree, so we get the same position of the previously was its vertices. So order of rotation for the rhombus is 2 and angle of rotation is 180 degree. Next is equilateral triangle. So we know that number of line of symmetries in an equilateral triangle is 3. So its center of rotation is intersection point of its medians. So by this center when it rotated, so as we consider in the previous sessions also, in equilateral triangle when it rotated by 120 degree, so it will looks exactly same as it was. So by 120 degree, that means about 3 turns it will reaches its previous position. So we can say angle of rotation is 120 degree and order of rotation is 3. Now as we are observing on the screen that there is a regular hexagon, so center of rotation will be the intersection point of all its 6 diagonals. So this is the point. So this is the point where the regular hexagon will be rotate, and by the angle, so the angle for this rotation for a regular hexagon, now when we consider this triangle, this is the triangle that, and it is an equilateral triangle, so all the 3 sides are equal. So when it will turn, so here we are getting the angle is 60 degree. So when it turn by 60 degree angle, so as it is, it will look like same. So this is the 1 turn, 2 turn, then it will be 3 turn, this one is 4th turn, 5th turn and 6th turn. So order of rotation is 6 times when we rotate the regular hexagon by 60 degree angle, so it will look like same. So order of rotation is 6 and angle of rotation is 60 degree. Now consider a circle. As we know that a circle, its center is intersection point of the diameter. When we draw the 2 diameters of the circle, so the diameter intersect each other inside of a circle, that is the center of the circle. So center of rotation is center of the circle, which is the midpoint of the diagonal, or we can say which is the intersection point of the 2 diagonals. Okay. Now when we rotate any circle, so by any angle we can rotate and circle will look like as it was in the circular shape previously. That meaning when the Number of line of symmetries, we talk about the number of line of symmetries for a circle. So it has infinite number of line of symmetries. So here when we rotate it by a 1 degree angle also, so circle will look like same as its appearance. So we can say every angle for the 360 degree, that means in the angle for a circle that is 360 degree. So we can say 1 degree angle is also angle of rotation, or 30 degree angle, it is also an angle of rotation, or 60 degree also a rotation angle. So every angle of the circle will be considered as angle of rotation. So here order of rotational symmetry for a circle is infinite, but angle of rotation may be any 1 degree of the circle from 0 to 360 degree. Now when we consider a semicircle, semicircle will be the diameter. So here when we take the figure of the semicircle, so it will look like this. Okay, so we can say whatever the midpoint of the diagonals, that will be the center of rotation. Now number of line of symmetry when we draw on a semicircle, so how we can draw like this. So number of line of symmetries is 1 in a semicircle. So when it will turn by 180 degree, so how it will be looks in this way, and again when it will rotate, so it will appear as it was previous. Okay, so the order of rotation in this figure from one turn, which is for 180 degree, so we are not getting the semicircle as its previous position, but then if it is rotate by complete angle 360 degree, then we can say this two figures are same. So here we are getting that angle of rotation is 360 degree, whereas its order of rotation is 1, because only in one turn the semicircle looks like an or we can say it fits its previous position, so only by one turn, so it will be the 360 degree angle. So in this way we have to find out the number of line of symmetries and the angle of rotation.